our project is the video processing server. Like we described last time, our project is basically, we're going to be expecting there to be videos that are going to be submitted to a database. Our job is to create an API for this database and also a video processing manager for the back end of this video processing server. Basically what we do is we're going to take videos from this database and run them through specified video processing algorithms. And so what the API there is therefore is to streamline this process of being able to communicate with the database no matter what database it is, or if the video processing manager and the database are in separate locations, you can still have communications smoothly. And also, the video processing manager is there to be able to ping the database occasionally, get proper videos, run them through the specified algorithms, and then retrieve the results and submit them back to the database. So that was basically just a summary of the project so far. No, we'll talk about that later. So we're going to do a quick demo of what we have built so far. We'll go over the iteration backlog in a bit, but right now we're going to go over the API which we built and show you a little bit of that. But first, we're going to show our test coverage. So yeah, this is our test. We have 100% covered on everything, and all files are being tested. And so if we go ahead and say npm start, we're going to start our API. And then we're going to be using Postman to send requests between our API to simulate the video process manager sending requests to this API. So we're going to go here. So for the video process manager, the first thing it would do is it would ping the database for videos which require processing. And basically, videos which require processing, in our case, are going to be videos which have requests in this request field on the database. So this is the MongoDB database we have set up. The schema basically has 4 sections to the table. It has an ID for every video, a video location.
Can you increase the font size, please?
Yeah, Control plus. Okay. Is that better?
Yeah.
Okay. Yeah, so it has an ID, a video location, which isn't concrete yet. The sponsor said we could either use a binary object or a video path. So we're sticking to a video path at this point, unless told otherwise. We have a request, which is an array of strings, and it basically is supposed to hold the names of the functions the video wants to be processed with. It can be multiple algorithms. And then results is going to be an object of objects. It's going to be an object where the keys are the name of the algorithms which have been processed, and the value is going to be the object that is returned from those algorithms. This will make a little bit more sense in a bit. But basically, what the database wants to return is every single video where there is something in the request field. So in this case, there is an algo 6 that it wants to be processed in here. And I don't know, if I go all the way down here, there might be an algo 3 right here. So the first thing the process manager will do is it's going to get a GET request from the path retrieve. And so this is running locally right now, but it could be on some other server somewhere. So we would send a post request or a GET request, and so it would return back to us a list of all the objects of every video. So this is exactly what you saw in the database. Here's the ID, the video location, the requests which need to be processed, and the results which are here to be appended to. And so this is sending all the objects right now which have something in the requests field. And so presumably the video process manager is going to take these, do processing on them, collect all the information, and send it back. So to send the results back, it would be sending it to the submit path, and it's going to be a post request. And so there's only three things that are needed when posting a video result. So all we need is the ID of the video to know where to put the result in, and then the requests which have been processed to know, potentially speaking, maybe if one algorithm fails or one algorithm didn't get processed. We want to know which algorithms it actually executed on and is returning the results of. So this request field is telling us what algorithms it actually processed. And the results is just like I said, it's an object containing the key being the algorithm name and the values being what the algorithm returned. And so it's going to send an object of this format to submit. And in this case, it's going to say results successfully submitted. However, to test this, we should probably go back and get a GET request actually, just so I can see, I can get a legitimate ID from here. So this one has algo 6, and I can get a legit ID from here and paste it in here. Okay, there we go, and algo 6, and it's going to be returning algo 6. The data really doesn't matter. So we can submit this and see how the database is going to change. Okay, results successfully submitted. And so if we update, I believe there was a C at the end of this ID, so we'll look for that. This was C9. So what we see here is the request field now is empty. So we remove the algo 6 request from the request field, and then it already had some results in this results in the results for this video already. So what we did is we appended the results for algorithm 6 to the current results instead of overwriting the current results. So if midway a request comes in for a video, and this video has already been processed by other algorithms potentially, this will not overwrite the previous results. And it will remove the request, so we know that that video does not have any more requests anymore. In relation to if we were to do another request for an algorithm which is already in this results table, we are relying on the front end to be able to check whether or not a result is present before submitting a request, because we are not the ones who submit requests. Otherwise, if a request is put in for a result that's already there, it's going to overwrite that specific result. So if algo 2 was put in the request again, we would think that they would explicitly want algo 2 to be run again and overwrite the previous results. Well, we gotta show some errors first. So I guess we could go through some error checking as well. So let's say we perform, let's say this field ID was not present, okay? And then you say foo, or something like that. We wouldn't be able to identify, not something like that. We wouldn't be able to identify which video it is because there's no ID field, and we wouldn't know where to look for this ID, even though it's specifically there. So in this case, if we submit this, it is going to tell us that there's an incorrect request format and we have a missing field. So this is some error check that we've done. Furthermore, if for some reason we have an ID that is not in the database, we're going to say ID is not found. If, trying to think what other error handling we performed. If, oh, yeah, I'll get to that in a second. I'm just gonna do another, or I'll just go with it. If I can get an object which has, okay, so like here. So if I for some reason, instead of passing an array in here, pass a 5, Where what? An extra 5? Okay, yeah. So if I have like an extra 5 here, like this won't be able to process. Requests is not an array of lists. So in this case, it should say that cannot post. Yeah, I didn't put a path. Yeah, so that's another error handling, but this is automatically done by Express Library for us. It's just saying we cannot post to this because there's no path. So root cannot be posted to. That's an automatic error handling for us. But if I were to put in submit, we'd say incorrect request data types, and there's several other similar error handling that we implemented to be able to make sure that everything is seamlessly integrated and there's no conflicts with data or processing. Nothing holds unexpectedly. I believe that is it for the demonstration.
So I will be going over the iteration backlog. Okay. So this is basically our checklist of tasks that we had to do for this iteration. Our first checkpoint was to design, set up, and implement a database to test and interact with API. We did that over here with MongoDB.
Yeah, so we're using Atlas Cloud, MongoDB, as our database for testing. Currently, the database which will be used by our sponsor is, he doesn't know what he's undecided.
Yeah.
So basically he told us we can use whatever we want for testing. And so we chose MongoDB for that case.
Also because it's not global and it's easier to just for all of us to
Yes,
connect.
we're all able to connect and test on different machines without having to have something locally.
The second thing on our checklist was to interface with the database to retrieve our data. I actually have a UML diagram set up to display that a little bit because we can't really show our code. Interface with that. So yeah, we have that over here with index and return database. It shows the connections between the two classes. Next on our iteration backlog was direct functionality to read object and return data in need of processing. I believe we handle that over here with database utils and also within return database, the return database class. Creating a starting draft of the database schema.
That is what we presented initially with the table of data types. So
This is basically just an ERD of our database. It's the same as what's in MongoDB. As you can see, we have an attribute for ID, which is going to be our unique key. We have an attribute for video location. You notice these two are blacked in because they're mandatory attributes, meaning like the table cannot exist without having an ID and location. Okay. We have our request attribute, which is a multi-valued array of strings, as we indicated by the double circle. That actually should be over, this should be over here. And same thing with results. If you can have multiple results to one, you can have multiple results for one object depending on how many times that or how many different algorithms have been run. Okay. Last thing on here was to receive and process requests externally from the video processing manager to the external API. We can go back again to the UML diagram, and I just forgot what I read. Okay, yeah, so this is our API package over here, which basically kind of goes in depth into all of our functions that we have used. In database communications, we have things like submit, collect, update. This is basically how the API interacts with our database, which is MongoDB. And I believe that's all we really have to present. So this is our project backlog. The left is stuff that we still have left to do.
So a lot of things that we went over which we completed. One of the things we completed that was actually not part of this iteration is we set up an S3 server for video storage. The sponsor doesn't exactly know how he wants everything stored for now, but we will be needing some form of being able to get videos in order to test them. So we said we should make a video storage server to be able to do tests. So we have this video storage server set up. In second iteration, we will hopefully be writing functions to be able to retrieve and download videos from the video process manager. As you can see, we have completed the entire API. We have set up the database, and we have completed the schema. So everything in first iteration has been completed. As we promised, our API is completely asynchronous. Although that's with a lot of help from the framework Express, but there's no I/O blocking. Multiple requests can be handled at the same time, quotes, or seem like they're being handled at the same time. So for some unfinished things, while our project is still a little ambiguous, we don't have the algorithms. But we are expecting to make this video process manager, which is going to interface with these algorithms. And at the time being, we're expecting to be mocking these algorithms out, or something like that. And to be able to set up this video process manager to be able to schedule videos for processing and collecting the data. Furthermore, one thing that we were thinking about adding to the API, and we briefly talked to the sponsor about it, but we need to get confirmation, is potentially adding in some sort of authentication. However, the sponsor was very vague about this. He did mention that he would like the API could be on another server separate from the process manager. And he might not want other people pinging from unknown sources. So initially we were thinking of some sort of pre-shared key. However, this could be an issue if the data is not encrypted. However, the solution is, since the API is only going to be communicating with the process manager, we can set up a symmetric encryption with pre-known keys to be able to encrypt the data. This way, we won't have to deal with certificates or public keys or asymmetric encryption, so it'd be very easy to perform something like this. Yes, and so we also will sometime in the future be setting up Dockers for everything. So for the API, the process manager, and we still have to hash out the specific details with our sponsor. And besides that, that is the general gist of what we have been told. We don't know too much about the future scope yet. And we are going to meet again with our sponsor this week, as we have every week, to discuss potential next steps. So I think I went over everything in the project backlog. Potential, or some difficulties that we faced. So most difficulties that we faced were with the ambiguity of the project. Initially, our first iteration was going to focus on interfacing with the algorithms. So we would know beforehand what type of data we'd be returning, or we'd be getting, or how would we process this data, or how would we call these functions, all that, which seemed kind of unknown to us, as opposed to communicating with the database, which is a little bit more structured. However, since the algorithms are not complete yet, we had to postpone that and start working on the API first. And so now we're transitioning over to the process manager, and maybe the sponsor will give us some samples to work with, or we mock out the algorithm in some sense. Also, communication with our sponsor has been a little difficult as well. He hasn't been in with us every week, but meetings are short, and so we need to meet with him a little bit more often. And so that was one of the difficulties of just, we initially did wrote a few pieces of code that were not necessary, as we had been confused about what the goals were initially, but we clarified that. Another issue would just be splitting work, because the group is very large, and we need to be able to have everybody contribute while having a balance between not everybody working on the same piece together at the same time. Because sometimes it seems like
like there's times when we've worked over things, we've had people work on things, and then we've pushed a refactor, and that person's work has just been completely overwritten. So it's just
yeah, more communication. Sometimes it feels like there's not too much to be done, so it feels like everybody's just working on the same thing. So that's just the difficulties that come with coordinating with a large team. And besides that, we haven't had too much headaches otherwise.